Our software has a timed mode and a patient-triggered mode. We will now simulate the patient-triggered mode. Upon inspiration, physiologically, the patient's lungs expand to draw air inside. Mathematically, this results in a pressure drop inside the ventilation tubing, which is read by our pressure sensor. This allows us to determine when the patient initiates inspiration. We then deliver flow by actuating our scuba regulators, such that the total pressure experienced by the lungs is a combination of their negative pressure and our positive pressure in order to create the desired peak inspiratory pressure. In this simulation, we use a square wave function generator to simulate the patient's attempted inhalation. You can see this in the graph to the right. As the patient attempts to inhale, the measured pressure drops. The pressure is shown in centimeters of water. We've loaded our Warrior Breath software onto the virtual Arduino seen here. You can see the servo motors turn to the proper locations in order to supplement the attempted breath and inhalation and provide the specified expiratory pressure during exhalation. These servo motors precisely adjust the pressures of oxygen and air that we let into the inlet tube. And as always, the oxygen concentration is tightly regulated to the physician-specified FiO2. Again, the servo motors turn very slowly in this simulation, which is the byproduct of the simulation software. Our real servos actuate instantaneously. We've added a few safety features to this program. First, we sample the pressure at every 500 milliseconds. This is important to robustly capture the pressure drop that signals an attempted inhalation. Second, the clinician can specify inspiration time in our user interface. So, if we sense that the patient is trying to inspire, we will hold the supplemented inspiratory breath for the specified number of seconds. And lastly, we allow for at least a 2-second expiration after each inspiration as a fail-safe measure.